This question number 6. It says a biased four-sided die is numbered 1, 3, 5, and 7. The probability of obtaining each score is proportional to that score. So basically, if your score can be 1, sorry, this is your score can be 1, it can be 3, it can be 5, it can be 7. So it says the probability of obtaining each score is proportional to that score. So we can suppose that this probability is going to be x, this is 3x, this is 5x, and this is 7x. And since the sum of all these probabilities is 1, so you can add all of them, which is 16x, and you put that equal to 1. This gives you x as 1 over 16. So therefore, now you have the probability of getting this 1 is 1 over 16. This 3 is going to be 3 over, this is 3 over 16. This one is 5 over 16. And this one is 7 over 16. ठीक है बच्चों, so these are the probabilities of these events separately. ठीक है, so that was what meaning proportional to that score. So you just suppose it's x as that a constant of proportionality, and then you got to that x, and then you have determined their probabilities. It says find the expected number of times that the die will be rolled up to and including the roll on which the first non-prime number is obtained. So it's asking for the expected number of the times, okay? So here, let me say that for this A part that X is geometrically distributed, and this is, he's asking for the non-prime number, okay? Which one is a non-prime number here? Out of this 1, 3, 5, and 7?
1.
1. So its probability is 1 over 16. So he's asking for E of x. So we know that that is 1 over p. Therefore, this is 16. So that means it is the 16th trial which is expected to have this 1 coming for the very first time. Okay? In this B part, it says find the probability of the first prime number. Now be very careful. It says the first prime number. Before this, he was asking about the first non-prime number. So we have to change this distribution now. Let's say y is, I can't use the same terms here. So now it's a prime number. So prime number, if this is only the prime, I mean the non-prime number, these are the prime numbers here. So this is the probability to get a prime number. So that is going to be 15 over 16. So it says is obtained on the third roll of the die. So it's basically asking for the probability that y is equal to 3. So this is um, q square times p. So now your p is 15 over 16 and your q is 1 over 16. So that is why this will be 1 over 16 square times 15 over 16. That is how you will get to this probability. Okay, so this was a question that was very frequently asked from the other groups. And then we have another question that was asked many of the students. That was the 7th question. It says the Sylvia and the theory are members of a choir. The probabilities that the perfect, they can sing a perfect high C tone on each attempt are 4 over 7 and 5 over 7. Just read that question and let me set this stage for you guys. Okay, so so probability that this Sylvie, how do you pronounce this? Is such a difficult name. Both the names are very difficult for me to pronounce. Okay, this is 5 over 8. Now it says, who is expected to fail fewer times before singing a high C note for the first time? So let's find this E of S for the Sylvie. That is going to be 7 over 4. And for this theory, this is going to be 8 over 5. If I write this as a decimal, this is going to be 1.75 and this is going to be 1.6. Whose E whose mean is less. Hmm? क्यों बच्चों? Whose mean is less? Yes. Now you have seen that this mean is is less. So this means this will be failing for the lesser number of times before singing that perfectly. Okay. So this theory is the one who is going to make fail fewer times before singing a high C note for the first time. Okay, so that was your A part. It says find the probability that both Sylvie and Theory succeed in a single high C note on their second attempt. Okay, so this means you have to find probability S equal to 2 and to find probability T equal to 2. Okay, and or I think just a minute. So let me complete this. So this was that Sylvie sings correctly on her second attempt. This is a probability, and this is for the theory on the second attempt. And then we multiply them. This is where they are both going to sing on their second attempt correctly. So this, they say this is the right answer. Okay. Now there's one more question. Let me find that question and then I take you there. Okay, it says a standard deck of 52 playing cards has an equal number of hearts, spades, clubs, and diamonds. A deck is shuffled and a card is randomly selected. Let X the number of cards selected up to and including the first diamond. ठीक है? अच्छा यहाँ पे पहली बात जो है that he should make clear that when you pick a card you have to replace that, otherwise this cannot be modeled as a geometric distribution है ना, because in a geometric distribution and binomial distribution we have to have the fixed probabilities. The probabilities of success has to be constant throughout. So if you're going to pick a card, you must replace that. Okay? So it says in this A part, given X follows a geometric distribution, describe the way in which the cards are selected. So that is the way where you should pick a card, and before you pick the second card, the first card has to be replaced. Okay? And the reason for this is that we want the probabilities to be remain fixed. Okay? It says, now we're going to pick, what are we going to, yeah, the first diamond, okay? So you see, the ones who play these cards, they know that there are 13 hearts, 13 spades, 13 clubs, 13 diamonds. So quarter of the cards, they are going to be the diamonds. So it says in the B1 that X is equal to E of X. So let me write it as X is geometrically distributed with this probability of success. So let's find first of all that what is E of X. So you know that E of X is 1 over P. So this is going to be 4. So that means it is expected that if you pick the fourth card, that would be the first diamond there. Okay. Now this first part, it says the probability that X is equal to E of X. So he's asking basically that X is equal to 4. So this is going to be Q cube times P. If your P is 1 over 4, then your Q is going to be 3 over 4. So this is 3 over 4 Q times 1 over 4. That is how you will do this first part. Then it says neither of the first two cards selected is a heart and the first diamond is the third card selected. This is a very interesting part here. We had bounded our brains, our thoughts up to the geometric distribution, but this question had nothing to do with the geometric distribution. It says neither of the first two cards selected is a heart and the first diamond is a third card. So indirectly saying neither of the first two cards are a heart or a diamond. So it means the first two cards are either the spade or the clubs. Hai. So that makes half of the whole pack of the cards, okay? Or the deck of the cards. So this is going to be half into half into 1 over 4, because the first card is going to be one of these two. The second card is going to be one of these two. And the third card is going to be a diamond. So that is why its probability is going to be 1 over 16. Okay? And there is one last question that is from exercise 7C, I think. Okay, the sixth question from exercise 7C, it says, it is known that 80% of the customers at a store own a discount card, okay? So the probability that they have a discount card is going to be 0.8. Um, and he's going to talk about the discount card. So I'm going to write this P as zero point 0.8 and Q as zero point 0.2. Okay. He says customers queuing at a checkpoint, checkout are asked if they own a discount card. Find the probability that the first customer who owns a discount card is the third customer. So he's asking in A1 that probability X equal to 3. So that is going to be 0.2 square times 0.8. Okay? We go on to the second part. No problem with that. It says not one of the first 4 customers asked. Okay? So this means probability X is greater than 4. Greater than 4. Okay, so none of the first 4 had the card. So that is going to be, if I show you on the number line, this is your 4 here. So this means this is going to be 1 minus the probability X is less than or equal to 4, which is simply going to be Q raised to power 4. That means none of the first 4, they had a card. Okay, so this is going to be 0.2 raised to power 4. Any problem up to this, bacha? क्यों भाई? हेलो?
सर हम 1 से सब्ट्रैक्ट नहीं करेंगे 0.
We have done that, beta, because this is 1 minus probability X is less than or equal to 4. So that is why this is going to be Q raised to power 4. You see, first one asked, he can have. The second one can have. The third one can have. The fourth one can have. Or all 4 didn't have the card. That is what we are doing right now here. He
ओके
said,
सर आई गॉट
okay,
इट
okay.
थैंक यू
Now, this is a B part where I should mention Shiza Atif. She helped us to solve this question correctly. So this is basically, again, I'm telling you that this depends on our comprehension skills to solve these, to be able to understand that what is the question about, okay? Now it says, given the 10% of the cards with the discount cards, forget to bring them to the store. Okay, find the probability that the first customer who owns a discount card and remembered. This is what we have to focus on. So let's find the probability that a person owns a discount card and remembers it. So this is going to be zero point 0.8 times zero point 0.9. That is your 0.72. And let's call this, I mean, A is geometrically distributed and this is 0.72. Now this is a separate distribution where we have those who own a discount card and they also remember to bring that, okay? So then it says, mm, where we were, it is going to be the second customer asked. So this is going to be probability A equal to 2. So that is Q times P. This is, if your P is, this is your P here, and your Q is going to be 0.28. This is 0.28 times 0.72. That is how they say you get the correct answer. So guys, I have discussed some of the annoying questions from these exercises 7C and 7D. Okay, the rest is up to you. You guys need to practice this. The more you practice, the more you will have grasp or your hold on this topic. Thank you very much.